Now that we've sorted out our representation of environments, let's return and look at interp using that new representation, or at least the abstract values and operations that construct those representations. So here again I'm showing an interp. I'm showing code that is parsed implicitly in a box, and instead of the bubble now I'm drawing the environment as the second argument, still leaving out the list of definitions to keep the slide simpler. So what happens now when we interpret this let expression? Well, we evaluate the expression 1 and find out that it should replace x, and so as we evaluate the body let y2, then we extend the environment. The old environment we had was the empty environment, so we add on the binding that x goes to 1. Once again, we'll evaluate 2 to get the value 2 back for y, and so we'll extend our current environment with that information. And you see this is just the same as the picture with bubbles, but writing it out with PLAI typed expressions instead of drawing the yellow bubbles. Eventually, we get down to y, and we will interpret the y expression in this particular environment, and we'll use the lookup function on the symbol y in this environment, and we'll get back a 2. Looking at the code for interp then, you see we have an environment argument as the second argument, with the expression still first and the list of functions last. In the case of a number, or a plus or a mult, nothing is really changed because these just pass along the environment. Locally, environment is along for the ride because plus and mult and num don't need to consult the environment directly. The environment is here for the identifier case, and in this case we have s, which is a symbol. So to evaluate the symbol s, it used to be that we had a free variable error here, but now it's possible that s is in the environment. And so we call the lookup function to find s in the environment. Let's skip application for a moment and go on to let's see, our local binding form. In this case, the template would suggest that we interpret the right-hand side and the body, since those are both expressions. And in fact, we do always want to just interpret the right-hand side with the natural recursion. After we get a value back, though, to interpret the body, we need to put this into the environment first. So when we evaluate the right-hand side, we get a value back that should be bound to a particular name. That name is the first part of the let's see. So we take that value and put it together with the name in using bind. This is a new binding that we want to add to our environment. Our environment is env, so we use extend env to add this binding to the environment. And finally, we take this extended environment, that's exactly what we need to evaluate the body, to interpret the body. So we have interp of body using that extended environment where our list of definitions remains unchanged. Similar things happen with the application form, which is where we used to have subst. We're replacing subst with environments. So again, the template suggests that we interpret the argument, and that is the right way to start because the argument is interpreted with the current environment. Once we get a value back for the argument, that should be replaced. That value should replace the function's argument name in the function's body. So remember, the way we get the function argument name is ftc-arg, because ft is the function that we found. So we're again binding the function argument name to the actual argument value. Once we've done that, we can start evaluating the body of the function. So we're going to interpret the body of the function using this binding and still the same set of definitions. There is a little catch here, though. There's a little part that's different from extend env down here. And let's look at an example. Suppose I have let y is 2, and then I call this function bad. The reason this function is called bad is because it takes an argument x and then it adds x to y. But if you see this function by itself, then y is a free variable. This should be an error when you run it. However, we have, in the context of the call, we have let y is 2. This y, if we do substitution, substitutes here, and there's no y, so this y should have no effect. Since we're deferring, though, we don't bother looking, and we just remember that y is equal to 2. Now we call the bad function, we look it up, we find out that x needs to be replaced by 10. So we're going to do that, but as we do that, should we keep the y as equal to 2? No, we should not, because if we did, then this y would be 2, whereas this y didn't have a surrounding binding, and this y didn't apply to anything that was directly in the body here. What that means is that when you call a function, you build up a substitution for the argument. You add the argument binding into the environment, but you start with an empty environment because when you start calling a function, before you bind the argument, no substitutions have applied. In other words, we create this binding here, and the environment that we extend with extendM is just the empty environment. And at this point, our interpreter is complete, and it actually has become simpler than by adding environments than when we had substitution, because we no longer need a substitution function.